Hello, today I'd like to talk to you about how to solve linear equations. It's a fundamental topic in algebra, and fortunately it's fairly easy to do. There are several properties and identities that relate to this topic, all of which boil down to two key principles for solving linear algebra equations. The principles are as follows. Those of you who have taken high school chemistry might think of an algebra equation as like a chemical balance. A chemical balance is a tool that's used to mass a specific substance by placing that substance in one pan and placing known masses in the other pan until the two pans balance. When they balance, you know the mass of the substance because it's equal to the known masses in the other pan. An equation is like a chemical balance in the sense that it has two sides, and the equal sign implies that the quantity on one side is equal to the quantity on the other side. So therefore, if you make a change on the left-hand side of the equation, that equation will then be out of balance unless you make an equivalent change on the right-hand side. The chemical balance works on the basis of it being balanced. Similarly, an equation works the same way. It works when it's in balance. When you think about it, a large part of solving an equation involves getting rid of stuff that you don't want in order to get the variable by itself, which is what you do want. Principle 2 states that in order to get rid of that stuff you don't want, you do the opposite of what that stuff is doing. As a simple example, let's say I wanted to solve the equation x plus 7 equals 12. That means in order to get x by itself, I'd have to get rid of the 7. Since the 7 is being added to x, in order to get rid of it, I would subtract 7. Let's now solve some equations to see these principles in action. Here's the first equation. To solve this equation, that means we want to get x by itself. X would be by itself were it not for the 2 and the 7. So the 2 and the 7 are the things to get rid of. Let's get rid of the 7 first. Since the 7 is being added to 2x, to get rid of the 7, we'll do the opposite and subtract 7. In accordance to principle 1, since we're subtracting 7 on the left side, we must also subtract 7 on the right side. Now the only thing to get rid of in order to solve for x is the 2. Since 2x means 2 times x, to get rid of the 2 we'll use division. That means we'll divide both sides by 2. Now we'll look at an equation that's somewhat more interesting, but one that nonetheless we should be able to solve using the same principles. We'll first use the distributive property and multiply 2 by the quantity 3x plus 1. We'll next simplify the right-hand side by combining the like terms 6x and negative x. 6x and negative x is the same as saying 6x minus 1x. 6x minus 1x giving us 5x. We can see now that we're making some progress. In order to solve for the x, all we have to do now is get rid of the 5 and the 2. Let's get rid of the 2 first. Since the 2 is being added in the expression, to get rid of it we'll subtract 2 on both sides of the equation. Now all we have to do is get rid of the 5. Since 5x means that 5 is being multiplied by x, we'll get rid of the 5 by dividing by 5 on both sides of the equation. Let's now look at an equation that has a fraction in it. Strong hint here. If you don't like fractions in your equations, one way to get rid of a fraction in an equation is by multiplying both sides of the equation by the denominator in that fraction. If your equation happens to have more than one fraction in it, you can get rid of all of the fractions by multiplying both sides of the equation by the least common denominator of all of the fractions. You'll see what I mean. To get rid of the 1/2 in the equation, we'll multiply both sides of the equation by 2. We'll next simplify the right-hand side by distributing the 2. And voila, no more fractions. Next, we'll simplify by combining like terms on the right-hand side. Finally, we'll get rid of the 3 by dividing by 3 on both sides. As a final example, we'll look at an equation that has the variable on both sides. You'll find that the same rules apply. Our first move to solve this equation will be to use the distributive property to get rid of the parentheses on both sides. Next, we'll combine like terms on the left-hand side. As you can see, we have expressions in b on both sides of the equal sign. That's pretty easy to fix, actually. All we have to do is subtract 15b from both sides. Now we're back on familiar turf, so to speak. We'll next add 36 to both sides. Our final move will be to divide both sides by -13. Notice that we have to divide by -13 because it's -13 that's being multiplied by b on the left-hand side. I hope you found this video on solving linear equations helpful, and I wish you luck on your future algebra studies. Thanks for watching.